Hey friends, welcome back to Civil Engineering Mastery. Slab is one of the major structural element which is covering the roof area. When compared to other structural elements, slabs are consuming more area. That means more concrete area. For example, if you take a column, beam or a footing, when compared to those structural elements, slabs are consuming more area. As we all know that slabs are covering the roof area, but how do we calculate the loads which is coming on the slab? Through slab only, the loads are transferred to other structural elements. So how do we calculate the load in slab? In this video, let's discuss in detail about how the slab loads are distributed to beams with detailed explanation. With that being said, let's begin now. First, let's see what are all the loads coming under slab. Under gravity load, we have dead load and live load. Dead load includes self-weight of the structure, floor finish load, sunk load, and waterproofing load. This waterproofing load will come on the roof slab. Always we have to provide waterproofing in the roof slab according to the material what we are using for waterproofing. So that load we need to consider. And next one is live load. Let's calculate the self-weight now. For calculating self-weight, we need to know the thickness of the slab. Here, thickness is considered as 5 inches. Always self-weight has to be calculated by thickness multiplied by the unit weight of RCC. So, 5 inches 125 mm multiplied by 25 kilonewton per meter cube is the unit weight of RCC. So, that comes around 3.125 kilonewton per meter square. This is the self-weight of the slab. Next, floor finish. We use different type of materials for floor finish, whether it may be a tiles or marbles or granite, whatever it may be. According to the weight of the material, we need to calculate the floor finish load. Here, thickness is 3 inches. Thickness also it is main factor. Floor finish thickness, so that is 3 inches, 75 mm, and unit weight of that floor finish is 20 kilonewton per meter cube. So we got 1.5 kilonewton per meter square as a floor finish load. Next one is sunk load. So this we get wherever we get porticos, toilets or utility area. In that places we get sunk slab. Sunk slab means the slab will not be on the same level of other slabs. Here you can see this is the level actually. Actually the slab has to come here, but it is 10 inches down from the top level. So that is called sunk slab. So this slab is called sunk slab. So this area we need to fill with the filling material. For toilet area, utility areas and all, for providing the pipe connections, we need some space. So for that space, we have to use this area, and then we need to fill the area with filling materials. Here the thickness is 10 inches. So the slab is sunk by 10 inches. Filling material is cinder. Unit weight of cinder filling is 8 kilonewton per meter cube. So sunk load is equal to 10 inches thickness multiplied by unit weight. So we get 2 kilonewton per meter square. So apart from self-weight of the slab and floor finish, in this kind of sunk slab, we get 2 kilonewton per meter square additional load as a sunk load. From this image, you can understand clearly this is the sunk slab and this is the floor, bathroom floor level. As I told you, here it is 10 inches, right? You just imagine the slab is sunken by 10 inches. So this is the floor level. This sunk area is used for pipelines like this, for bathroom and all. For pipelines, we have to use this area, and we need to fill this area with the filling material. So that is what we have taken here as a cinder filling. So that load also we need to consider on this slab. Next one is waterproofing load. Depending on the waterproofing material, we need to consider this load. This is applicable only on roof slab. For example, if you are constructing G+3 floors, G+4 floors, means it will not come in the middle floors. Only on the terrace floor we apply this waterproofing. So on the terrace floor only we need to consider this waterproofing load. We consider 1 to 2 kilonewton per meter square generally as a waterproofing load on roof slab. Next, live load. Live load as per IS 875 part 2 for residential building, it is 2 kilonewton per meter square. It will not be same for all other buildings. In IS 875 part 2, it is clearly mentioned for all types of building. For example, what is the live load for commercial building? What is the live load for school building? What is the live load for commercial shopping building and hospital building? Everything is mentioned in IS 875 part 2. Now let me show you you one-way slab and two-way slab in framing plan. According to the load distribution, we have two types of slabs. One is one-way slab and another one is two-way slab. So how do we identify which is one-way slab and which is two-way slab? Generally, we have the slab dimensions, that is LX and LY. LX is the shorter dimension, LY is the longer dimension. If LY by LX is greater than 2, then it is one-way slab. If LY by LX is less than 2, then it is two-way slab. So in this way you can identify which is one-way slab and which is two-way slab. Consider this slab. This is the one-way slab. The notation for one-way slab is like this. That means only load will transfer to this side and this side. Here LY by LX is greater than 2, so that is why it is a one-way slab. LY is the longer direction, LX is the shorter direction. So the slab will bend in the shorter direction, shorter span. So that is why we provide main reinforcement in shorter direction and secondary reinforcement in longer direction. Secondary reinforcement in the sense it is the distribution bar. So that we provide in the longer direction. In one-way slab, we provide main reinforcement in shorter direction only because the slab will bend only in one direction. LY by LX is greater than 2. These are all the main points you have to remember while considering the one-way slab. Similarly, coming to two-way slab, this is the two-way slab. This is the notation for two-way slab. That means the slab will bend in all directions. The load will get transferred into all the four directions. This is the LX shorter span. This is LY. Here LY by LX is less than 2. That is why it is a two-way slab. When compared to one-way slab, in two-way slab we provide main reinforcement in both directions since the slab bends in both the directions. So here shorter direction also we provide main reinforcement. Similarly, we provide main reinforcement in longer direction as well. Now let me explain you the load distribution in one-way slab. This is the longer span 3.8 meter. This is the shorter span 1.8 meter. Let's consider this one as B1, this one as B2. LY by LX is equal to 3.8 by 1.8, which is 2.1. So this is greater than 2. It is a one-way slab. Slab thickness is 125 mm. Let's calculate the load. First we need to calculate the self weight. So slab thickness we know and unit weight of RCC we know. From that we can calculate the self weight. Next floor finish, that is 75 mm thick. So we get 1.5 kilonewton per meter square. Next live load 2 kilonewton per meter square. So first we need to calculate the dead weight of the slab. What are all the dead weights are coming? Here self weight and floor finish only we have taken. As I have explained you before, if there is any sunk load is coming on this slab, you need to add that load also with this dead load. And if it is a roof slab, if you are doing waterproofing, then you have to add that load as well with this dead load. And finally live load is 2 kilonewton per meter square. Total load on slab is 6.625 kilonewton per meter square. Total load includes dead load plus live load. So self weight, floor finish and live load. If any other dead loads are coming, you have to add that load as well. Now let's calculate the load. As I said before, in one-way slab, the load will get transferred in only one direction. That means like in the shorter direction only, the load will get transferred. So the load will get distributed to this beam and this beam. These two beams will not get any load from one-way slab. Here LX is 1.8. Always, whether it is a one-way slab or two-way slab, you have to consider the span as a shorter span only. Even somebody may ask you that what is the span of the slab. Whether it may be a one-way slab or two-way slab, you have to always consider the shorter span as the span of the slab. This is very, very important. Please do remember this. Let's calculate LY by LX, that is 2.1. So it is a one-way slab. Total load on slab we know 6.625 kilonewton per meter square. This includes dead load plus live load. So how the load will get distributed here? We know the total load coming on slab. So that load is divided into 2. That is W load into LX by, this is the shorter span. This is the shorter span, right? 1.8 meter. So the total load is getting divided into 2 parts. So that's why W LX by 2. So this is the span. Always you have to consider the shorter span only. 6.625 multiplied by 1.8 divided by 2, we get 5.9 0.96 kilonewton per meter as load on beam 1. Similarly, the same load will goes to this beam as well. Along with that, we need to add the self weight of the slab. So this is how you have to distribute the one-way slab load to the beams. Here you can see how the slab bends when the load is acting on the slab. One-way slab is bending only in one direction, in the shorter direction only. So that is why we provide, in order to arrest this bending, we provide main reinforcement in the shorter direction. So that reinforcement will not allow the slab to bend like this under the application of load. This is the main reason. Why do we provide main reinforcement in shorter direction in one-way slab. Next, let's see two-way slab load distribution. So this is the longer span 3 meter. This is the shorter span 2 meter. Ly by Lx, if you calculate, it is 1.5, which is less than 2. So it is a two-way slab. Here also the same slab thickness, that is 125 mm. So as per IS 456-2000, class number 24.5, loads on supporting beams. The loads on beams supporting solid slabs spanning in two directions at right angles and supporting uniformly distributed loads may be assumed to be in accordance with figure 7. In IS 456-2000, it is clearly mentioned two-way slab load distribution has to be like this, like in the right angles, the 45-degree angle dispersion. This is a trapezoidal portion and this is the triangle portion. The angle between these two is 45 degree. So you can come to know from this picture, this area, trapezoidal area load will go to beam 1 and this area, triangular area load will go to beam 2. That is what given here. Load in this shaded area to be carried by beam B. This is beam B, and load in this shaded area to be carried by beam A. Next, let's start with the calculation. Let's calculate the load on B1. How do we calculate this trapezoidal area load? So here Lx is 2 meter. As I said before, always span of the slab is the shorter span only. Lx is 2 meter and total load on slab we know 6.625 kilonewton per meter square. Trapezoidal load distribution we need to find out. So what is the formula for that? W Lx by 2 into 1 minus 1 divided by 3k square. Here W is the load, Lx is the shorter span and k is equal to Ly by Lx. So this value we need to consider. I have substituted all the values, load, span, and then 1 minus 1 divided by 3 multiplied by k. So k is Ly by Lx, that value is 1. So by solving this we get 5.64 kilonewton per meter. So this trapezoidal load is 5.64 kilonewton per meter, which is coming on this beam 1. Similarly, the same load will goes to this beam as well. Now let's calculate the load on B2. Lx is 2 meter. Load on slab is 6.625. Triangular load distribution is WLX by 3. So this is the formula to calculate the triangular load. We know W is total load, Lx is the shorter span. So by calculating we get 4.416 kilonewton per meter. So load on beam 2 is 4.416 kilonewton per meter. So along with this we need to add the self weight of the beam as well. So this is how you have to calculate the two-way slab load. Let me show you the one-way slab and two-way slab reinforcement here. See, this S7 is the one-way slab. This is the shorter span and this is the longer span. So this Ly by Lx value is greater than 2. So it is a one-way slab. In one-way slab, we have provided the main reinforcement in only one direction, that too in the shorter direction. In the longer direction, we have to provide the distribution bar. That is what it is written here, distribution T8 at 12 inches center to center. Main bar reinforcement is T8 at 6 inch center to center. So this is the main reinforcement. In this direction, we have to provide the distribution bar. See here, S6 is the two-way slab. In two-way slab, we have provided the main reinforcement in shorter direction as well as in the longer direction. I hope now you have clearly understood about this concept of one-way slab and two-way slab under the action of load. One-way slab bends in one direction, two-way slab bends in two directions. So friends, I hope you all like this video. Please do comment in the comment box. Your comments are always welcome. Super thanks button has been enabled in our channel. If you like this content, if the content is very useful to you, please log in to your email ID and then click on the super thanks button below this video and support this channel by paying some amount. If you like this video, please do share it with your friends. Don't forget to subscribe this channel for more videos. Thank you for watching.